Alright, so what we got going on, this is the review for the mole conversion test thingy that's coming up on Wednesday, December 7th, I think? Yeah, Wednesday, December 7th. Alright, now here's the deal. This is making an announcement for everybody that's listening to it. The only day that you can make up this test, if you, let's say you take the test on Wednesday and you don't finish it in time because it is SOC schedule, it is your responsibility to arrange to be after school on Wednesday. Otherwise, we have after school is the only day on Wednesday that you can complete it. I can't have this stretching on because, you know, we got that whole finals thing coming up next week. So Wednesday, tomorrow, after school, or during lunch is the only days that you can come in and make this up. Other than that, that's pretty much it. Alright, that being said, let's go ahead and let's get started. So to draw the molar roadmap, you are going to put in grams, moles, and particles.
Is it atoms, units, molecules, and
C, senor. I'll get to that in a second. Alright, I'm going to switch colors here. Alright, to go from particles to moles, you're going to put 1 mole on top and 6.02 times 10 to the 23rd on bottom. And then over here, to go from moles to grams, you're going to do molar mass on top and 1 mole on bottom. Now, if you start off in grams and you go to moles, what's going to be on top, guys? 1 mole. What's going to be on bottom? Molar mass. Very good. All right, and then if we're going from moles to particles, what's it going to be? 6.02 times 10 to the 23rd on top over 1 mole. All right, so what is a mole? All right, so mole is basically a counting number. All right, it's like a dozen. How much is a dozen? 12. Okay, so like a dozen donuts, a dozen cows, a dozen kids, a dozen tests. It's all 12. So if I have 5 moles of calcium hydroxide, I also know that that will be roughly equivalent to 5 moles of chlorine gas. All right, it's the exact same number of atoms. They might be different sizes. So if I have 5 tests and if I have 5 dozen tests and 5 dozen people, are they going to take up the same amount of size?
Yes.
Really? 5 dozen tests and 5 dozen people are going to take up the same size?
No.
Oh, no.
No. I got 60 people and 60 tests. Let's say that they're average, normal grown-ups. No. They're about the size of the piece of paper in front of you. Yeah. Anyway, so and that's exactly the same thing. 1 mole of water is 18.02 grams. Okay, we know that by the molar mass. That is not that big. But 1 mole of lead is going to be really freaking heavy because a mole of lead is 207.2 grams. That's nearly a pound of lead versus 18.02 grams of water, which is not even an ounce of water. Okay? So it just tells us what all is going on inside of there. All right, so let's see here. I want to do that and that. Okay, so let's scroll down here. All right. All right, so what is Avogadro's number and why is it useful? All right, anybody remember what Avogadro's number is? 6.02 times 10 to the 23rd. All right, now that's particles. And that tells you how many atoms, ions, units, or molecules. There's actually 4. Some people don't include ions, but I do. Anyway, molecules are in 1 mole. What? Because it tells you how many atoms, ions, molecules are in 1 mole. Okay? That's what I was trying to explain. It's answering to 2 questions in 1 answer. All right. Any other questions? All right. So that's the nice little fluffy theory side down. Let's go to some hard facts in science. All right. Calcium sulfate. Find the molar mass. I graded your guys' percent composition homework. It wasn't good, but the main reason why was because you got the wrong formula. Okay? That was the main reason. It wasn't that you didn't know how to do it, is that you got the wrong formula. So let's go over this together. Calcium sulfate. Calcium is what symbol? And what's the charge for calcium? All right, sulfate is SO4 2 minus. So 2 plus 2 minus gives you, cancels out to do what? Good. CaSO4. Now we need to find the molar mass. All right, so to find the molar mass, we take the molar mass of calcium, which is 40.08, plus, what's the molar mass of sulfur? Plus, what? Y times 4. Good. So we do 16 times 4. We add it up, and that is our molar mass units of grams per mole. Now again, I don't care about the destination, I care about the journey. So let's move on to the next problem. I don't care about the destination, I care about the journey. All right. Now here's the other thing. I am partial to giving really hard complex problems like this one, aluminum sulfate, because it involves a lot of skill in order to solve it. First thing you got to get right is what? The formula. So what is the symbol for aluminum? And what's the charge? Plus 3. Sulfite is what? Close. It's SO3 2 minus. Now you got to pay real close attention to the endings. ITE usually implies that there is an ATE. All right. So if we look at sulfate, that's SO4. If we look at sulfite, it's SO3. Nitrate is NO3, and nitrite is NO2. So if you're talking about the ITE version of it, it's going to be less than the ATE version of it. Now, what do you think it is if it's IDE? Where are you going to find this at most of the time? On the periodic table, with 2 exceptions, cyanide and hydroxide. Okay? So you got to pay real close, careful attention to this part right here. Sulfite, SO3 2 minus. Now, do these charges cancel out? No, they do not. So what we have to do is put our parentheses around this guy right here. We crisscross the charge, and it becomes Al2, parentheses, SO3, parentheses, 3. This is why I like doing these kinds of formulas, because it's really complex and takes a while. All right. What's up, Victor? This 3? So that right there comes from the aluminum. The charge goes to the outside of it. Good? You sure? All right, so now we're going to add up everything. So we're going to do 2 times something plus something times something plus something times something. So this is our AL, our S, and our O. So how many ALs do I have in the problem? 2. What's the mass of AL? All right, how many S's do I have? And then what's the mass of S? 32.07. Then how many O's do I have? You sure it's not 6? 9. Why? You multiply, you don't add. All right, and then it's 16. And again, I don't care about the destination. I care about the journey. We've completed our journey. Hoorah. All right, moving on. Let's see. Scroll down here. Water, sodium carbonate. Nah, I don't care about those. All right, so let's look at these as. You guys can do 7 and 8 on your own. That will help you out, get you some more practice. All right, which one of these guys has the smallest molar mass? Well, for this one, here's what you got to look at. What I would suggest that you do, you have 2 ways of doing this. Way number 1 is that you put in all the numbers, you figure out all the problems, you have to put your calculator keys working overtime. Way number 2, list everything out that you would put into your calculator first. So what's potassium? What's the mass of potassium? 39.1. for potassium, plus what's chlorine? 4, 5. All right. So now list out what would you put in your calculator for calcium oxide to figure out that molar mass. Plus. All right. What would you put in for sodium oxide? So you're going to put 2 times 22.99 because there's 2 sodiums plus 16. What about carbon monoxide? What's carbon? Plus what? Now I want you to notice something. What is the same in 3 out of the 4 of these? Oxygen, right? So which one of these answers can we automatically eliminate? A, because that's going to be way bigger than the rest of them. All right. Now B, C, and D all have 16, so we ignore those 16s. So we look over here. Which one of these guys is going to be the smallest? D, right? Carbon monoxide. Coincidentally, it's 28.01, and this one is something, and that one's something else. It's higher than what it is. Okay? So that's how you know without even putting in any numbers into the problem. That's how you know. Okay? If you really want to do all that work and calculating the numbers and whatnot, hey, go for it. More power to you. All right, questions on that stuff so far? Negative? All right. So I'm going to break up the video here, and then we'll come back here in the second part.